Hey guys! So today we're going to be talking about the nervous system, and the specific part that we're going to be talking about of the nervous system is the peripheral nervous system. Now, the peripheral nervous system is composed of two parts mainly, the afferent nerves and the efferent nerves. So what the afferent nerves are going to do is they're going to bring in sensory information to the CNS, to the central nervous system. An example is your cutaneous receptors. And your cutaneous receptors are going to detect things such as heat, such as pressure, such as pain, all that stuff, and then your afferent nerves are going to bring that information to your central nervous system. Now, we also have efferent nerves, and efferent nerves are divided even more. Efferent nerves are going to be divided into somatic nerves and autonomic nerves. Now let's look at somatic nerves first. So somatic nerves are going to be what innervate skeletal muscle. And what that means is that it's going to be able to make skeletal muscle contract, right? And the way it's going to do that is by using neurotransmitters. So at the terminal buton, it's going to release acetylcholine, and then that acetylcholine is going to be received by nicotinic receptors on the skeletal muscle. Okay? And then that's going to cause muscle contraction, always. Now, just to review, the neurotransmitter is acetylcholine and the receptor is nicotinic. Okay? Now we move on to autonomic nerves. The autonomic nerves are divided even more. We have the sympathetic and the parasympathetic. Now with the sympathetic nervous system, we're going to see short pre-ganglionic neurons and relatively long post-ganglionic neurons, right here and right here. Now, the synapses between the pre-ganglionic neuron with the post-ganglionic neuron, we're going to see acetylcholine as the neurotransmitter and nicotinic receptors as the receptors. And this is because we always want it to be excitatory. We don't want the signal to stop here. We want it to continue through. So once we get enough nicotinic receptors open and we have the sodium coming in, and then we have a lot of EPSPs, excitatory postsynaptic potentials, then we can have a threshold stimulus, right? And then that will cause us to depolarize the neuron and cause an action potential to propagate through the axon. And then once we get to the terminal butons of this axon, we're going to have norepinephrine, epinephrine, or even dopamine used as the neurotransmitter. And these are going to bind to adrenergic receptors. Now some examples of adrenergic receptors are alpha-1, alpha-2, and beta-1 and beta-2. Now the alpha-1 and the alpha-2 are going to be responsible for an increase in intracellular calcium. Now they're also going to be responsible for blocking cyclic AMP. And an example of where you can find these adrenergic receptors is in your blood vessels, right? It's going to be responsible for vasoconstriction of your blood vessels. Now the beta-1 and the beta-2 are going to increase the production of cyclic AMP. An example of where you can find these is in your heart. So these receptors are going to cause an increase in heart rate and an increase in strength of contraction. And we'll look more into that in a little later. Okay? Now jumping more into the parasympathetic nervous system, we have long preganglionic neurons and short postganglionic neurons. Now, what we see between the synapses of the preganglionic and the postganglionic are the same. We have acetylcholine as the neurotransmitter, and we have nicotinic receptors as the receptors. Now, at the postganglionic terminal buton, we have acetylcholine as the neurotransmitter. Now, this might have you thinking, hey, that's going to be excitatory. Not necessarily, because now our receptor is a muscarinic receptor. And muscarinic receptors can either be excitatory or inhibitory. An example of how they can be inhibitory is in the heart. They will decrease your heart rate, which isn't always a bad thing. So they can decrease the heart rate. Okay? And what else? All postganglionic neurons are unmyelinated in the parasympathetic and in the sympathetic nervous system. Okay? And now that you kind of have a better understanding of what pre-ganglionic neurons and post-ganglionic neurons are, we can go back to the somatic nerves, and I can tell you now that these nerve fibers do not synapse after leaving the CNS. So there's just one long axon traveling from the central nervous system to the skeletal muscle. One long axon, compared to here, where you have two axons. Okay? And one last thing has to do with the adrenergic receptors. So we have norepinephrine and epinephrine as our neurotransmitter, and then those are going to bind to their adrenergic receptors. Now, those can be taken off in two ways, with MAO, M-A-O, or COMT, C-O-M-T. What MAO is it's monoamine oxidase. It's going to break down the neurotransmitter so that it can be removed off of the receptor. Same thing with COMT, catecholamine O-methyltransferase. It can be used to remove the neurotransmitter off of the receptor. Okay? And then, I should mention acetylcholine. Acetylcholine is removed off of its receptor by acetylcholinesterase. And that is produced by the postsynaptic membrane. Cool. And I think I covered it all. So, thank you guys for watching.